Hello, so today we are going to take a look at this problem called count substrings with one values. And so the problem is essentially we get a string and we want to count the number of substrings that contains only one. And the string contains only 0 and 1 values. So if I illustrate with an example, let's take this one in the middle here. So we have this one alone, right? And then we have this one here. But that's the only two substrings with one values that we have here. Like this one should not be considered 0 because it contains 0. And so here we can say we have 2, right? This is the value here. For the next example, here we have this one here, and then we have this one. So each one constitutes a substring with only that one, and then we have with 2. So we have that, and then we have just 2 ones. That's also a substring, a different substring, right, of length 2. So here, the answer is 3. If we go look at this a little bit more complicated example, we have this one here, and then we have all these 3 ones in the middle, and then we have these 2 ones in the end. And then we have this third string, this here has 2 and 1, right? This, and then it has this and this. So it has also one. The one here we already counted it, right? So we shouldn't count it again. But it does have another different substring of length only 1, right? of length 2, right? And so we have another 2 here, and then we have the entire string itself. So 3 ones, and then we have this last one here of 2. So you can see here we have 3, 4, 5, 6, and then we have 1, 2, 3, 4. So overall we have 10. So this is what we are trying to solve, is find the number of substrings that have only values 1, only value 1, right? Okay, so let's see how we can solve this. So if I take this example here, we have 0, 1, 0, 1, 1, 1, 0, 1, 1. So one thing we can notice is that if we take each group of 1 elements, like this group, and this group, and then count, because the substrings that we want, the condition is that they have to have all 1s, right? You can't have, like, the substrings we want to count, you can't have 0s. We want to just have 1s. So what we can do here is just take each group separately and just count how many substring in that group, and aggregate all of them and sum them up and return that as the result, right? So to just get the groups, we know that we could just take, so this is the string that we have, right, as an input. So to get the groups, we know we can just do, well, s.split. In Python, for example, we can just split by 0, and then we'll get the group. So in this case, we'll get 1, 3 ones, and then 2 ones, right? Then the next step would be for a substring like 1, 1, like how many substrings are in this one that contains only 1? So that becomes our problem. Substrings in that, so just how many substrings are in it. We don't need to worry about only 1s because by definition it contains only 1s. And so to do this, I'm just going to change the notation a little bit so that we can explore this, because with just 1s it's hard to know which one we are talking about. So let's just represent this with ABC, right? So with ABC, what we have here is, we know that if we can just consider only those starting from A, right? And then we will get A, AB, and AC. So A, AB, and AC, ABC. So these are substring starting from A, or from basically the first element, right? Then once we do that, now we could just go next with only those that are starting from B, right? So if we continue having this, we'll just take these starting from B. And so we would have B and then BC. And then the next step would be, what we have left is just C, right? So we have left only C. So one thing you can notice if you look at this is that, well, n here is equal to 3, right? The length. So first we have 3 elements to work with, but once we do those starting from A, then we have only starting from B, so we have only n minus 1 elements to work with. And now here we have only 1 to work with, right? And so how many substrings do we have here? So here we have 3, here we have 2, and here we have 1, right? So we can see here that the sum of all of the substrings that we have is 3 plus 2 plus 1. But the main idea here is that once we take the substrings that are starting only from the first element, then what we have left, substrings that we have left, that are only the substring that are starting from the other element, not from the first element. So we would take, and then those starting from the second one, and then after that we take those starting from the third, and then we keep going like that. And so each time we start out with n possible elements, right, n possible ways to construct the substrings, and then after that we have only n minus 1 letters left, and then after that we have only n minus 2, and depending on the length of the string, so for this string it stops here because at that point we reach the last element, but you keep going until you reach the last element, right, where you can't choose only that last element, there is no other substring. And so this formula here is very known. So you could also write it the other way around, which is 1 plus 2 plus 3 plus 4, and keep going until plus n. And this is pretty much the definition of arithmetic progression. And by definition, for an arithmetic progression, the sum is, especially for one that is starting from 1 to n. For the general arithmetic progression, there is specific definition. We don't have to get into it. You can look it up. But for this specific one, where we have starting from 1, and the progression term is just d here is equal to 1 up until n, the sum is known to be n multiplied by n plus 1 divided by 2, right? So since the number of substrings that we have in a string like this is by definition this, such that n is the length of the string. So we could just use that and find for each group how many substrings and then sum that up. So that makes it pretty straightforward to do. So let's just try to write this quickly here in Python. So we would have our function, let's call it count substrings of ones, and we get a string. So the first step, as we said, would be to split them by 0, and so we'd get let's say so we would split by 0. That would mean we can get the groups of 1, so let's call them ones. So this would be a list, right? And then from there we could, for each group, right, use this formula to compute how many substrings are there. And that we can just take the length and basically we would need just a variable to keep track of the sum. So let's have a result equal to 0 here, and we could just add to the result each time. So that would be res plus n multiplied by n plus 1 divided by 2. And then once we do that, at the end we can just return res. And that's pretty much it for this solution. So to summarize here, what we've done is we got all the groups of ones separately using this, and then we counted for each group how many substrings are there using the fact that it's an arithmetic progression and that has a common difference of 1, and we could just use n multiplied by n plus 1 divided by 2, and then sum that up, essentially. Yeah. So now in terms of time complexity for this problem, for this solution here, we go through the array once here. So at most n, right? If we have like, for example, just groups of length maybe n divided by 2 ones or something like that, but at most it would be O of n. And so n is the length of the string. In terms of space complexity, for this specific solution, we are using this array here of groups of ones that adds extra space, where at most also we will have n groups of ones. So solution here is also of n space complexity. Okay, so I have here the solution that we just saw in the overview, where we split by 0 to get the groups of ones, and then we just for each one we take the size, and then we add the number of substrings, and then we return that at the end. And a couple of test cases just to make sure we didn't mess up anything, and seems to pass, so cool. Now, is there any other way we can solve this? Let's see. So one thing we can use is a group by in Python. So how can we use group by here? So let's just take this and write a second solution here. So the way we can use this is so group by will just group based on the key would be the value, and then for this one, for example, the key would be 0, and the content, the value would be just the list of 0. For the second group, it would be 1, and then 3 ones. The group after that, it would be 0, and then the value is just 0, and then for the next one, the key is 1, and the value is 2 ones. So you get the idea. It just groups them sequentially by the key, which is the value of the list here. And so what we will have here, if we iterate on it, we'll have the key and the group itself. And then from there, we of course need to import this group by, which comes from a Python module called itotools. So from itotools, import group by. And here we need, of course, the res variable to keep track, to count how many substrings we have. And we are not interested on keys of value 0 because we don't want to count those. And so we could just say if the key is equal to 1, then we count. And we count using the same mechanism we did here, which is we take the group and the so the group here, though, is an itertool group, kind of. So we need to convert it to a list so that we can take the length. And from there, we could just return the result. So it kind of saves us from having this extra space here because we will be iterating immediately on the groups. And it's also kind of shorter. So if we run this using this method, test cases pass as well. Okay, so that's it for this problem. Thanks for watching, and see you on the next one.